Assalamualaikum warahmatullahi wabarakatuh. Today, our group will present about X86 and ARM instruction format. Okay, next slide. Okay, this group consists of 7 members, which are INTAN SAZREEN, AMIR AIZAT, myself, FATIMAH AZZAHRA, ANISAH NORDIN, MOHAMAD ADIB, and NADHIRA. Okay, next. Okay, first, I will talk about introduction of X86. Okay, first, X86 is an Intel CPU architecture used to denote the microprocessor family released after the original X86 processor. It was originated with the 60-bit X86 processor in 1978, which denotes the microprocessor family on the basis of the Intel X86 and X88 microprocessors. And generally, X86 is the term for Intel processors that comprises of 2x6, 3x6, 4x6, and 5x6 processors. In modern times, the term X86 is used to denote to any 32-bit processor that ensures backward compatibility for X86 instruction set architectures. Since the full name of the processors is X02x6, X03x6, X04x6, and X05x6. Therefore, the term X86 is short for active time 86. Typically, the ACT is used to avoid redundancy. Next, in starting, X86 began with an 8-bit instruction set. Then, as technology grew up day by day, and it started with 80 and 32-bit instruction sets. In almost any kind of computer, X86 microprocessors can run the computer servers and laptops, and from supercomputers to desktops. However, the software may not run by older processors that need to be optimized for newer X86 processors. Multiple new features have been added to the X86 architectures in its 40 years of existence. Its remarkable achievement is almost entirely backward compatible. Third, modern 64-bit processors may refer to as AMD 64. However, they are also known as X86_64. In the early 2000s, in terms of the AMD 64 label, it was at the forefront of 64-bit processing technology. The term X86 was made on the basis of the original Intel X86 chip that was finishing with the number 86. The additional segment registers are included with the X86 processor that makes it capable of accessing several data segments at the same interval. Regardless of segment registers, it also supports code segment register and additional stack segment register. Fourth, a computer uses an Intel processor if its technical specification describes that it is based upon the X86 architecture. Okay, and the numbers cannot be trademarked. They only offer a simple way to differentiate processor types. Okay, this is the reason that Intel's 586 processor is called a Pentium processor. However, the numbers are used by software developers to refer processors. Okay, the fifth, with the help of setting the virtual X86 mode flag, the X86 processor can be converted to a high-speed X86 processor. The efficiency of the platforms on the basis of X86 with the help of virtualization improves significantly considering operating systems, single servers, and a single application. Next, when dealing with the processing of data transactions and databases, enterprise workloads that involve high-end computing, X86 has significant disadvantages as compared to other processors. There must be considered scalability requirements, architecture, workload profile, and operating system while selecting X86-based platforms. Okay, lastly, the reason why X86 refers to a 32-bit system because the X86 processor was designed in a way and more common that has the potential to understand big machine language at first. X86 were known as the X86 architecture as they kept 86 at the end of the modern number. I will pass to the next one.
Next will be the introduction of the ARM. So the term instruction format refers to a common machine instructions format that the central processing unit can directly decode and execute, which is CPU. A machine instructions layout is defined by a series of bits, which is binary 0 or 1, which are known as the instruction format. The number of bits in the machine instructions consist of 0 and 1. These bits are categorized into groups known as fields, which is include opcode, operands, and addressing mode. Which is opcode is the instructions to be executed, and operand the data on which the instructions are to be executed. The CPU or processor takes all the instructions from memory and decodes the bits to carry out the instructions. ARM is RISC based, which is a reduced instruction set computing. RISC is the latest of its kind, and in which activities are split or reduced into simple instructions and crunched in a second at a faster rate. That's it for me.
Okay. Assalamualaikum warahmatullahi wabarakatuh. My name is Norhana HAZAMIL. So the structure of instruction format, we have two which is ARM and X86. Okay. So for X86, we use encoding of instruction. Okay. X86 is CISC based. So what is CISC based? CISC is complex instructions sets computer. So CISC is a computer architecture in which single instruction is capable of performing many low-level action, multi-step operation, and addressing modes. So X86 use a variable length instruction format. So each instruction merely takes up the room necessary to express the operand. So operand is the data to be operated on. It is contain information, and its no memory space is unused twice. So this format essentially offers more option to address more operands. It is feasible to have efficient code, numerous instructions with different opcodes, but the same function suggests distinct addressing technique. So from figures, we can see from F1 is opcode. We have only 2 byte length instructions. It may have implied data or register operands. So when opcode is a task to be performed by CPU, and from F4 we have register to register. So we have 4 byte length instructions, and for F6 we have 5 byte length instruction, and F8 we have 8 byte length instructions. Okay. And ARM instruction format, we have 3 addresses architecture: general purpose register, direct addresses, and offset addresses. So 3 addresses architecture means having 3 operand inside the instruction. So the terms 3 address architectures refers to an instruction set, whereas the 2 operands Rn and Rm. So Rn is a first operand register and Rm is a second operand register. And the destination Rd. So Rd is a register which we know as destination for storing result of the instruction. So it this is can specify independently of each other. Okay, so from figures 13, we can see from data processing immediate shift, this is instructions. So we can simply read from Rm, which is 0 to 3 bytes. Okay, and from this figure, we have 3 operands which are RM, RD, and RN. And then we have opcode in 21 until 24. And we have certain condition, which is data processing, load store immediate, load store register, and load store multiple. Okay. And then from certain condition, from first is data processing. So data processing is may transfer data from one location to another location. Okay. So another from and for certain case like branch instructions, we have 3 operands are not required, which is RM, RN. So we don't have that. So when, for example, when we want to jump from one location from another location, we just require one address. We can use branch instructions. Okay, and then from we can see we have load and store. So there are separate instructions to load and store segment and length field for each load and store operations. So ARM instruction format include an opcode and implicitly or explicitly indicate the addressing mode for each operand. That's all from me. Thank you.
Thank you, Hannah, for the explanation about the structure of X86 and ARM processor in such a format. Now, I, ANISAH binti NORDIN, will explain about the characteristics of those two processors in such a format. Next. First of all, I will explain about the X86 characteristics of in such format. The first token opcode, which can be 1 to 3 bytes long. It is either completely or partially indicate the basic nature of the instruction. 1 byte token mode RM on the figure is further divided into a few of fields, which is mode, registration opcode, and RM. This segment of the token occupies n bits in that token. But mode RM may or may not exist is depending on the value of code. If the mode RM exists, the encoded representation of the register operand may be found in the value of the register opcode of the X86 processor. Next. Addressing mode. Addressing mode is another operand of the instruction of X86 processor. This addressing mode is determined by the values of mode RM, which is the token SIV, scale, index, byte, and the displacement. Last but not least, an operand of the immediate values in the token immediate may be used in the instruction of the X86 processor. Next. Next, I will also explain about the characteristics of ARM processor instruction format. This processor have bits length with each instruction are 32 bits long, which is 4 bytes. Segments registers comprise 132-bit 4 bytes, which I explained about earlier. Register to store the current 16-bit segment number and 2 32-bit registers to store the start address of the segment, and its length of the segments is represented in bytes. Not just about that, this ARM processor is divided into several fields that specify the operation to be performed, which is the source operand and the destination operand. Also, load store architecture, which is the data processing instructions, is act only on registers. Also, this load store architecture has three operand formats. Load, which is stored, the function is store instructions for memory data access. It also combines ALU, which is present as arithmetic logic unit, and shifter for high speed bit manipulation. Next. This processor this instruction of the processor can be conditionally executed in single instruction. The registers of this processor and immediate values are 32 bits wide, and the 32-bit mode and the 16 bits wide. In the 16-bit mode, registers are 8 bits wide for thumb modes only. Next, the next slide I will pass to the ADIB for the explanation about the major performance of the X86 and the ARM processor.
Okay, next is the major performance advantage and disadvantage processor X86 and ARM. For the advantage of X86 is widely used and well supported by its operating system and software. Support a wide range of instructions, including complex instructions for tasks such as floating point arithmetic and multimedia processing. X86 also has a relatively simple instruction format with most instructions using a fixed length format of 1 into 15 bytes. Lastly, X86 also support out of order execution, which allows the processor to reorder instruction to improve performance. Advantage for ARM. ARM is widely used in mobile device where power consumption and size are important consideration. ARM also use a reduced instruction set compared to X86, which can make it easier to write efficient code for ARM processor. ARM has a smaller code size compared to X86 due to the shorter instruction and the use of load or store instruction for memory access. ARM has a smaller die size compared to X86, which can lead to lower power consumption and heat generation. Lastly, ARM support a wide range of processor architecture, including both 32-bit and 64-bit design. For the disadvantage, X86 use a complex and powerful instruction set, which can make it more difficult to write efficient code for X86 processor. X86 disadvantage also has a larger code size compared to ARM due to the longer instruction and the need for the additional instruction to handle tasks such as memory access. Lastly, for the disadvantage, X86 has a larger die size compared to ARM, which can lead to higher power consumption and heat generation. Disadvantage for ARM. ARM has a more complex instruction format compared to X86, with instruction using variable length encoding and multiply instruction set for different tasks. ARM does not support out of order execution, which can limit its performance on certain type of workloads. Lastly, ARM has a limited set of instructions compared to X86, which can make it less suitable for tasks that require complex or specialized instruction. Thank you. Next.
Next, we have the conclusion. In summary, both processes of X86 and ARM architecture have their own pros and cons. Both processes contain a variety of capabilities. X86 processors are in charge of the mid-range section of servers, laptops, notebooks, and desktops, while ARM processors are widely consumer electronic devices such as smartphones, tablets, and other mobile devices. However, because our technology evolves so quickly, the development of future processes is very exciting. Both will be highly sought after in the future. That's all from me. Thank you.